We're going to go ahead and take a look at another definition for our trig functions. We've looked at SOHCAHTOA, we've looked at it being any point on our coordinate system, and now we're going to go ahead and take a look at what happens when it's on a unit circle. A unit circle means your radius is 1, meaning 1 unit. Now, if we use either one of the previous definitions, when we're looking at our unit circle, you'd be x units over y units up for your point. Your radius, because it's unit circle, would be 1. We would say the sine of t, t is your angle. If you use SOHCAHTOA, would be opposite of y over your hypotenuse of 1, or y. If you use the previous definition with any point, it would be your y over your r, but r in this case is 1. So either way, we get sine to be y. Similar, we get cosine to be adjacent over hypotenuse, or x. We get tangent to be opposite of y over adjacent of x, still y over x. So therefore, the reciprocal of tangent would be x over y. Here, the reciprocal of cosine is secant, so it'd be 1 over x. Similarly, the reciprocal of sine is cosecant, so it'd be 1 over y. So it's really the same as our previous definition that we had last section. However, the only difference is that we have a radius being 1. This definition that we're dealing with here, you will need to have memorized, as it will show up on your quizzes. So, what is the period? Well, because you go around your circle once is 2 pi. Once you go around more than once, it's going to repeat. So our period of sine and cosine is 2 pi. A periodic function goes so far before it starts to repeat, and then it repeats on that whole interval again and again. Here's a way to look at your sine curve. We had said sine is your y coordinate. So at 0, you're at a height of 0. At pi over 6, you got to go up that height, because we're looking at the sine of pi over 6, which would be your y coordinate. Then we go to pi over 3 and take the sine. We've got to take our y coordinate. So at pi over 3, we're going to be at the same height when we're looking at our sine curve. At pi over 2, so you're going to go pi over 2 to the right here, because as our curve goes around, that tells us how far we're going over. You got to take that height, which is 0. And then once again over here, at 3/4 pi, 3/4 pi is here. You go this curved distance over on your horizontal, and then however high you were on the unit circle is how high you are here. When you connect all those points, you end up getting this blue curve, which is referred to as your sine function. Here's your sine function. It's a nice smooth curve. Your domain, well, we have no restrictions on our domain. From what we looked at before, it's all real numbers. Your vertical asymptotes, we have no vertical asymptotes, so we have none. We then want to look at our range. Our range are the y values you would get out. Goes up to a height of 1 and goes down to a depth of -1, so your range goes from -1 to 1. X-intercepts, where are we crossing the x-axis here? Looks like at 0, at pi, at 2 pi. The next one then would be 3 pi, and then 4 pi. So pretty much it's just a multiple of pi. The y-intercept is where you cross the y-axis, and that is at a height of 0. Your period is how far you have to go here before it starts to repeat. You'll notice once you get over to here, it starts to give you the same output that we had over here. So it is 2 pi. Now, when we're looking at our symmetry, is it symmetrical about the origin or the y-axis? If it's symmetrical about the y-axis, it means each side's a mirror image of the other one. Symmetrical about the y-axis would be an even function. In this case, we're not symmetrical about the y-axis. We're symmetrical about the origin. which means if we would take our original graph here, rotate it 180 degrees about this point right here, it would end up being on top of itself. That's what we mean by being symmetrical about the origin and also being odd. So we're now doing pretty much the same thing, but we're looking at our cosine. Your cosine deals with the x-coordinate from your unit circle. So here at an angle of 0, your x-coordinate's 1. So here at an angle of pi over 2, your x-coordinate is 0. So you go over pi over 2 and you go up 0 here. Here you go all the way to pi, your x-coordinate's -1. So you go all the way over to pi, whatever the x-coordinate on the unit circle was, that's what we go here. If you would connect all those points and do that for all the points, you would get this blue graph. Once again, our cosine function is always continuous. We've talked about that before. We have no vertical asymptotes as you look at your graph here, so there are none. We want to find our range. Well, the highest your cosine function ever goes is 1. Lowest it ever goes is -1, so it's always between -1 and 1. Your x-intercepts are at pi over 2, 3 pi over 2. You have another one over here of -pi over 2. Your next one over here would be at 5 pi over 2. It looks like it's the odd multiples of pi all divided by 2. So a second way you could write that is pi over 2 plus any multiple of pi. Your y-intercept, where are you crossing the y-axis, is at a height of 1. Your period, how far do you have to go before it starts to repeat again? It starts to repeat right here once you get to 2 pi. Now, are we symmetrical about the y-axis where each side's the mirror image of each other? If it is, then we know it's even, which we are. So then we would say our symmetry is about the y-axis. We're then going to go ahead and look at our cosecant graph. Our cosecant we know is the reciprocal of sine. So I have the sine graph drawn in here. It's not part of our final answer, but it may help us. We go ahead and we know we're dealing with the reciprocal. So here at sine, we're at a height of 1. The reciprocal of 1 is 1. Here we're at a height of a half, so we know the reciprocal of a half is 2. Here we're at a height of a half. We know our reciprocal is 2. Here we'd be at a height of about a third, so you know your reciprocal is 3. Similarly over here. So you kind of get this horseshoe going up. But we do have a vertical asymptote here. We have a vertical asymptote because we'd have the reciprocal of 0, which would put 0 on the bottom and you'd be undefined. Similarly, you're going to have a horseshoe going down because when you take the reciprocal of these points, the reciprocal of a negative is still a negative. So our domain would really be all real numbers except where the vertical asymptotes are. The vertical asymptotes are occurring at 0, pi, 2 pi, and so on. So there's our vertical asymptote. So our domain is everything but that. So our domain is going to be all real numbers except multiples of pi. Your x-intercepts over here on the right never crosses the x-axis. Y-intercept, you'll notice your graph never crosses the y-axis because there's a vertical asymptote there. Your range, you'll notice you start at 1, you go up forever. You also start at -1, go down forever. Since we're dealing with the reciprocal of sine, our period is going to be the same thing as sine. So it's going to be 2 pi. Is it even or odd? It's going to follow exactly what sine did. And sine was symmetrical about the origin, so it's odd.